Can we use technology to overcome the challenges that people and organizations and countries face? That's really the pursuit here. In fact, that's why way back in 2016 is when we came out with the AI principles.
An innovative development in software architecture and artificial intelligence has been made possible by a groundbreaking partnership between Stanford University and Microsoft Research. By utilizing the unrivaled skills of GPT-4, the most recent language model of OpenAI, the research offers a paradigm-shifting idea known as Self-Thought Optimizer, or STOP. Are you excited to know more information about this? Let's see how this new innovation works and its benefit. Let's get started. The underlying idea behind this research is the possibility of optimizing practically any objective specified in natural language through interactions with a language model. The real innovation, however, is in the creation of scaffolding programs, which are carefully created by human programmers in languages like Python or orchestrate methodical interactions with language model. Transformational gains in programming performance are made possible by these scaffolding programs. Don't you think this technology is beyond the boundaries? A major realization has been made by researchers in the design of a scaffolding program transcends the limitations of any particular optimization issues and language model. It's a general idea that has great potential for developing AI-driven solutions everywhere. But how does this benefit? Do you have guesses? STOP starts off with an initial improver scaffolding software that makes use of a language model to better respond to difficulties. The recursive feature of STOP, in which the model iteratively improves the improver software, makes it unique. The outcomes are nothing less than outstanding. Researchers put STOP through a series of algorithmic tests to evaluate its performance. The results clearly show that the model develops over time, getting better at self-improvement with each iteration. This phenomenon shows how easily the language model can take on the function of meta-optimizers, the self-improvement tactics the model suggests, as well as how they translate into downstream activities, are the focus of this study. A balanced approach to AI development is ensured by its investigation of a potential risk connected to such self-improvement strategies. Researchers have been intrigued by the recursive self-improvement system for more than 50 years, but this discovery is a substantial advance. Instead of attempting to build all-encompassing AI system, STOP concentrates on the model's ability to improve the scaffold by repeatedly invoking it. This study beautifully describes the mathematical underpinning of the RSI code generation challenge. The enormous potential of RSI code generation is vividly illustrated by the STOP program. Even with a GPT-4 model trained on data up to 2021, some downstream tasks showed notable gains. It's crucial to talk about the ethical implications of such technology as we embrace its transformational possibilities, while emphasizing the value of protecting against unanticipated effects. The research carefully investigates the ethical evolution of AI systems like STOP. What are your thoughts on this? Have you ever wondered how STOP works with Microsoft? The model suggests using a genetic algorithm as one of its most popular strategies. In some crucial ways, many of these attempts were unfeasible. For instance, many of them would involve mutations that disturbs random characters or line or attempted crossover based on string combining, which is quite unlikely to succeed. However, some of the attempts were reasonable, relying on the language model to execute crossover and generate mutations. The model kept a list of all of its improvement attempts based on utility and expanded the best K in the list. Beam search was the most prevalent meta-heuristic we saw utilized by the model. This is the tree of thoughts method, which was developed years after the GPT-4 version we used for the training cutoff, are quite comparable. STOP chooses an improver based on the downstream utility enhancement. The rationale of this strategy is the assumption that programs that are effective at improving downstream solutions may also be effective in improving themselves. In a similar vein, it stands to reason that favoring single-round improvements would produce superior multi-round advances. This explores a meta-utility that, while covering both self-optimization and downstream optimization, is more expensive to analyze in the maximum formulation. A self-improved improver example after t equals 10 iterations. This method uses an epsilon greedy strategy to balance the usage of existing good solutions and the discovery of new ones. It also maintains a population of the best solutions. According to the respective rates of utility enhancement from exploration and exploration, epsilon is dynamically modified, with each exploration step corresponding to a higher temperature sample. Additionally, temperature is dynamically controlled to adjust the exploration-exploitation trade-off. Finally, for efficiency, an improved stopping criterion and reset mechanism are implemented. One option is to use temperature as an exploration parameter. The model is increasingly cautious in its investigation the closer it gets to exhausting its budget. This is somewhat similar to simulated annealing. However, it focused on improving the sample temperature rather than regulating the acceptance criteria for the change in utility of an improved solution. Since the utility function may be stochastic, reframing the optimization's target as a banded issue stresses selecting the best option from a set of sample improvements. This is another approach that sees the optimization's object as an exploration effort. Percentage of improvement attempts that were not sandboxed out of 10,000 confidence intervals. Both language models made an effort to execute code on a modest but non-zero portion of initial gates. STOP creates code improvers that increases the efficiency of code downstream. This work shows the self-optimizing language model do not require the model optimize its weight or underlying architecture. Strong scaffolding strategies must be tested, though otherwise, the capabilities of future language models may be misconstrued. Researchers can understand and reduce the risk of misusing increasingly potent language models by comprehending how language models enhance their scaffolding with STOP. Additionally, STOP might make it possible for researchers to test the efficacy of various methods for minimizing unfavorable self-improvement tactics. STOP is definitely an innovation that will provide amazing features. But did you know that STOP had limitations too? The language model itself is not enhanced, which is a fundamental flaw in our strategy. Additionally, our meta-utility metrics only directly influence quality through increases in task utility upstream. In contrast to some early works, any single improvement attempts may lead to worse performance, which may cause more degradation. Another drawback is that STOP requires a utility function that can be evaluated efficiently, which might not be feasible for many tasks. While other approaches might benefit from retaining a population or improvement framework just keeps one improver at each pace. While an improver could choose to sample from a population of implementation, this is not a type restriction and probably introduces bias. Sandbox flag deactivation is done by the language model ostensibly for efficiency, so it's crucial to carefully consider the advantages and disadvantages of researching RSI and, more especially, the modest improvement we make. The black box language model is not altered by STOP, making it a partial RSI. Furthermore, at this time, we do not think that the scaffolding systems STOP develops are superior to those that are manually engineered by professionals. However, it would be conceivable to include methods for API-based fine-tuning for closed models into the improvement loop as these became more widely accessible. As a result, it is challenging to determine the universality of our method, particularly with huge language models that are becoming more and more potent. This work is motivated by the fact that understanding how language models enhance their scaffolding in the STOP self-improvement cycle can help us comprehend the potentially reduce the detrimental effects of improved models. In the current investigation, they created STOP, a system for meta-optimizing language models to recursively optimize code production. We showed that powerful language models like GPT-4 can enhance code that makes use of the language model itself. STOP develops improvers that improve the performance of downstream code for a range of algorithmic tasks. This work shows that self-optimizing language models do not require that the model optimize its weight or underlying architecture. Strong scaffolding strategies must be tested, though otherwise the capabilities of future language models may be misconstrued. Researchers' understanding and the mitigation of the potential misuse of increasingly potent language models can be achieved by understanding the ways language models enhance their scaffolding with STOP. Additionally, STOP may enable researchers to test the efficacy of various methods for reducing the use of undesired self-improvement approaches. Systems have the ability to improve many crucial facets of quality of life, including education, health, and many others. We also acknowledge and consider seriously the potential drawbacks of AI technologies. The worries that recursively self-improving systems can have unanticipated negative effects, which have been raised by numerous writers, are of particular interest. What are your thoughts on such innovation? The launch of STOP and its proven effectiveness in enhancing AI-driven solutions marks a turning point in the market. With language models like GPT-4 influencing the development of AI technology and its applications, this invention opens the way to more effective and efficient software development. Businesses that take advantage of these developments stand to earn a considerable competitive edge in a rapidly changing artificial intelligence market. And that's all about it. If you find this video informative, please give a thumbs up. And if you like more updated AI news, subscribe to our channel. And don't forget to click on the bell icon to not miss out on any video and to get notified on time. Don't hesitate to give suggestions for our video. See you in the next one.